All right. I'm going to help y'all um, work through your review. So I just want to do kind of one of each problem so that there's no surprises on the test. Y'all get all the help that you need. So let's get started. So the first few problems of the test will ask you to solve quadratic equations. Now here's the thing. I do not care how you solve them. Okay. The problem will probably say solve it by factoring, solve it by quadratic formula, solve it by whatever. Whatever is the simplest method, solve it that way, okay? So this one, I'm gonna solve by factoring because I'm pretty sure this one can be factored, especially since that's the way they ask you to do it. So we need to find something that multiplies to 8 and adds to -9. So that's gonna be this 1 and 8 here. So y minus 1 y minus 8. Let's double check. -1 times -8 is +8, and they add to -9. So my two solutions are, if I set this to 0, okay, y minus 1 equals 0, I get 1. Y minus 8 equals 0, I get 8. So those are going to be my two solutions. All right, let's check out the next one. For x plus 41 plus 6 equals x plus 5. Okay, so the first thing I'm going to do is I'm going to try to isolate the square root, okay? Because I know I'm going to need to square it to undo it. So I'm going to do -6. And I get x minus 1 over here. So now I need to unsquare root. So I'm going to square both sides. X minus 1 squared. And we know a quick little trick for this. Basically, I'm just foiling this out. But we learned that shortcut, so I'm going to go ahead and use it here. All right. Now I have a quadratic again. So now I'm going to move everything over. Minus 4x, so this is going to be minus 6x, minus 41, so this is going to be minus 40. I'm going to check real quick and see if we can factor this, because that would be nice and easy if we could. 1 and 40, 2 and 20, 4 and 10, and that's, 5 and 8. I think that's all our possibilities. Now, is there something that multiplies to -40, adds to -6? There is. X minus 10, x plus 4. So my solutions are 10 and -4. But, okay, and this is a great way to lose points on this on your test. Whenever we squared, it's possible we created an extra solution. So let's try both of these and see if they work, okay? If I plug in 10 here, 4 times 10 is 40, plus 41, that's 81. Square root of 81 is 9. So 9 plus 6 is 15. Plug in 10 here, 10 plus 5 is 15. So this works. But now I got to check this -4. I don't think the -4 is going to work. I'm guessing that's our extraneous one, but let's try it. So 4 times -4, that's -16. Plus 41, that's 25. So square root of 25 is 5. 5 plus 6 is 11. -4 plus 5 is 1. 11 doesn't equal 1. So that is an extraneous solution. So your only solution here would be 10. Okay, please, 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 whenever you square both sides, you have to check for an extraneous solution to make sure it works. All right. So this next one, we have a parabola or maybe a quartic equation. Sorry, my markers are being goofy. And the vertex seems to be at 3, 2, okay? And it's asking over what intervals is this increasing, decreasing, or constant? Well, it seems to be increasing here. So what x values does that cover? Well, that's increasing from negative infinity to 3. And then over the rest, it seems to be decreasing. So it's decreasing from 3 to infinity. So that should be a nice, easy one for you. All right. Now we're looking for a linear function that has this point and this slope. And you might be saying, wait, what do you mean point? Well, that's what this is. You plug in an x, you get a y. So this is your point. That's your slope. All right. So we can use the point slope formula if we wish. There's a few ways to do this, but I'm just going to use the point slope formula. So my x that I plug in goes here. My y that I plug in goes here. So y minus 2. My slope is 7. My x is negative 2 here. Okay, so you'll notice this x and y, you don't plug anything in there. You want those to stay. So y minus 2 equals 7x plus 14. Y equals 7x plus 16. Okay. All right. The next problem, the first part is basically asking, hey, what do you think the parent function of this is going to look like? So if I give you something like this and I say, hey, what's the parent function going to look like? You need to see that this is a reciprocal function. That was flipped. Sorry. There we go. So the basic is going to look like that. And then the next part asks you to just find 2 points on the graph. Well, if you want to find 2 points on a graph, all you do is just shove in a couple x's there. It says not to use the origin, so don't use 0, 0, because it asks you to and asks you not to in the directions. So just pick a number. 0 would be a bad one because that's going to be undefined. But we could do 1. Okay, if we put in 1, we get 3 divided by 1, that's 3. So that's going to be a point on here. We could do 2. 3 divided by 2 is 3/2. And it doesn't matter what you pick. Just pick an x and a y that it spits out. Just make sure you don't use the origin. All right. This question gives you 2 points and asks for the slope. So actually it asks for the line, the equation that makes this true. So first thing we're going to do is we're going to find the slope. So I'm going to take my second y minus my first y, my second x minus my first x, because remember, we've got this change in y over change in x. Okay, so we get 2, we get 3. Our slope is 2/3. Okay, now we do our point slope, because we have a point and a slope, so we roll like that. So I don't know, I'll just pick this guy, I guess. Subtract our y1, slope x minus x1. Okay. 2/3 x plus, here's a trick, 2/3 times 3. If I'm multiplying by 3 and I'm dividing by 3, that just cancels. So I'm left with 2. Okay. If you want to check your work, you can always plug in an x and see if you get this y, and then plug in this x and see if you get this y. If you've done it correctly, both of those should come out right. All right, this one is asking us to do another quadratic. So if I want to solve a quadratic, again, this particular one, if I'm reading the problem, says that we need to solve it with the quadratic formula, but maybe we don't. Let's see. Let's move it over. All right. So 26, that's 1 and 26. 2 and 13, that's prime. So we are stuck, okay? Because none of these are going to add up to 2. So we are going to use the quadratic formula here. X equals negative b plus or minus square root b squared minus 4 ac. Ooh, this one's going to be imaginary. All over 2 times a, 2 times 1. All right. So let's see. This should be negative 2 plus or minus square root. I think this is 104. All right, we know what the square root of 100 is. That's 10. So square root of negative 100 is going to be 10i. These both divide by 2. We get negative 1 plus or minus 5i. So if it asks you for 2 separate answers, the first answer is negative 1 plus 5i, and the other one is negative 1 minus 5i. All right, this one, it's asking for the inverse function if possible. All right, so when in doubt, go ahead and try to find an inverse function, or you can graph it. This one's a cubic. So this one passes the vertical line test, but it also passes the horizontal line test. So there should be an inverse. To find the inverse, we switch our x and our y. All right. And now I'm going to solve for y. So add 4 to both sides. Divide by 2. Now, y to the 1/3, remember that's a cube root, okay? So the way that we would undo a cube root is third power. We just do the reciprocal power to undo this. So our inverse function winds up being x plus 4 over 2 to the third. Okay, that's our inverse function. Don't get confused by this notation. Remember, that just means inverse function. All right. Let's see. Okay, it's asking what the parent function will look like. Now, this one, since it's x to the 4th in the denominator, instead of having this look, it's going to have this look. Okay, this is what's going to give us that distinctive shape where it's the reciprocal, but it's also an even function. Okay, it's symmetrical. And since it's negative, that means we're going to be down here. Okay, so this would have been just the general shape. You can also shove that in Desmos if you wish. And again, it's going to ask us for 2 points. Well, what do? We just pick 2 x's and just shove them in there. So again, I don't want to shove 0 in there because that's going to be undefined, but let's shove a 1 in there. So if I shove a 1 in for my x, that's going to give me negative 8/3. Okay, 3 times 1. Okay, let me shove a negative 1 in there. I could have picked 2 had I wanted to. Negative 1 to the 4th is 1. So that's still negative 8/3. Okay. Boop, boop. All right. When you see this question on your test, you should rejoice. Because it's giving you a point, it's giving you a slope, but not just any point, okay? 0, -4, what's special about that point? It's on the y-axis, it's the y-intercept. Oh, so they gave me a slope and my y-intercept? Well, I better put that in slope-intercept form. Y equals -7x minus 4. All right, next problem. All right, so we've got the function x cubed minus 2. We've got the function x minus 2. And it wants to know what f of g of x is. Now remember, that is this. Okay, so our g of x, that is x minus 2. And then we're going to shove that into the f function. So we're going to do f minus 2 cubed minus 2. Now, this is not considered the simplified answer. They want you to go ahead and expand this out. That's really a matter of opinion if that's better or not, but this is not going to be an acceptable answer in Hawks. So let's go ahead and cube this. Now, you don't just cube each piece. We've got to cube the whole thing. Now, this we know how to do pretty easy. X squared minus 4x plus 4 using our little pattern. Now we're going to distribute. X cubed minus 4x squared plus 4x minus 2x squared minus 8x minus 8. And don't forget your minus 2. Now we just combine like terms. X to the third. I've got my squareds. I've got my x's. And I've got my constants. Okay, so that would be the composite function there. Now the domain. Well, what's the domain of this guy? All real numbers. What's the domain of this guy? All real numbers. So guess what? The composite is also all real numbers. So that's going to be your domain there. All right. We have a similar problem here. F of x equals x to the third minus 2. G of x is x minus 2. And we have g of f of x. And you might be thinking, isn't that the same thing? No, it's not. Because this time, we're taking the f function, which is x to the third minus 2, and we're shoving it in here for x. So x to the third minus 2 minus 2. So that just gives us x to the third minus 4. Okay, what's the domain? Again, all real numbers, so the composite will be all real numbers.